Basically, the idea is to build an app like Guess My Number. You set a range of numbers, a random number from 1 to 100. You type here like the number that you guess, and then you try to guess the name by writing 25 and pressing guess. And if this is a yes, so if this is true, that the user has correctly guessed the number, we go here and we continue the program here. Otherwise, if the user has incorrectly guessed the number, so if the answer to the question has the user correctly guessed the number is false, if the answer to that is false, we go here. So you create a function, you define a function, you pick a name, you enclose the code that will be executed. And then when you want to execute these instructions, you just use the function name with a set of parentheses. So now every time in your code that you run this command, play game parentheses, we say that you're calling a function. And you can see right now, when I call the function, it finds the function and it runs the code. If I run this function again, 4 times, the code will be reused 4 times. JavaScript went here and it ran this code 1, 2, 3, 4 times from the start. Basically, the idea is to build an app or small game like Guess My Number. So the Guess My Number, I found like this online game. You set a range of numbers. So you say, I'm going to guess a random number from 1 to 100. And you type here like the number that you're guessing. So now this program has picked a random number from 1 to 100. And then you try to guess the name by, I don't know, writing, let me write 25 and pressing guess. And if you happen to find the correct number, it will say, of course, hey, you found the number, you win, blah, blah. But if you haven't found the number, it will either say that your number is greater, the picked number is greater than the one that you picked. So in this case, the number is larger than 25, or is less than the one I wrote down. You try something else, and then you say, okay, it's greater than 50, so let me write 75. And now you know that the random number is above 50 and less than 75. So you start thinking, okay, it's somewhere between this range. So let me put 60. So it's greater than 60, but less than 70, and you go like this. And at some point, probably, I don't know, you'll find the number. Now I won't continue, but this is the idea of the game. So this is what we're going to build. And I'm going to start with a diagram. I'm not going to start coding because, as you can see in this quote, it says, and this is like a big lesson for every software developer, the sooner you start to code, the longer the program will take. Because the worst thing that you can do when you get an idea or you get like a project and a problem you try to solve in programming, the worst thing you can do is to start coding. The best thing you can do is to think about the problem, plan, design the solution, and then the last part is coding. So this is what we're going to do. We're going to start by planning, thinking, designing the overall architecture, the logic, the program logic, and then at the end, we're going to be implementing the code. Now, before going into this first phase, I'm just going to start by creating a project folder. So right here, I'm in a folder called Intro to JS. I'm going to create a folder called Number Guessing Game, just to have like a folder. I'm going to right click and open this in the integrated terminal in VS Code so that I can run commands such as git commands. And let me go here. So git status. When I run git status, Git sees that this is a folder that has not been initialized as a Git repository. So I'm going to start by initializing Git repository. We always want to work whenever we start a coding project by using Git. So I'm going to run git init to initialize this folder as a special kind of folder, as a repository folder, so that we can take snapshots and save commits and go back in time. So if I clear now and I do a git status, you will see that right now I'm inside a repository. This is a special folder now. I'm going to create a single file for this project. So a single number, let's say guessing game HTML. So I'm going to build an HTML file that will be the basis of my web page that will contain the game. I'm going to quickly create a basic HTML5 boilerplate. So a basic web page structure by using the exclamation point abbreviation and then pressing enter or tab to just create a basic page. I'm going to give it a title, so number guessing game. Then inside the body, I'm going to give it a heading, so number guessing game. This will be shown in the page body, and this will be shown in the tab when I open this up in the browser. I have live server installed, which let me like run this locally in a professional manner, served through a server. So I will open this, right click and open with live server so I can see it in my browser. You can see the page here. So now I can start, writing the code. Here's the H1, here's the H1, and the title is shown up in here. So this part shows in here and this one shows in here. This is like a basic boilerplate. I'm not going to start writing any other code. I'm just going to commit. I'm going to save these changes. I made an initial web page, so I'm going to write git status. I have an untracked file, this number guessing HTML that I just created. So let me save it. In Git, saving a file or taking a snapshot or a commit is using two commands, git add and git commit. So I'm going to run git add with the file name to stage this, to prepare this for saving. So this is step one for saving in Git. And then git commit, I'm going to create a message like added. So this is actually going to create a commit and save this, take a snapshot and save these changes with an accompanying message that will remind me that at this point in time, I added an HTML boilerplate. Everything looks good. Now, if type git log one line, you will see I made my first commit. This is the unique ID for the commit, and this is the message. So now when I make another change and another commit and another change and another commit, I will always keep a history of previous changes, previous commits, previous snapshots, so that I can travel back in time. Now I'm safe to move on. So before starting a project, always initializing a Git repository and then commit at particular points in time so that you keep every single step in Git's memory, and you can always go back in time and revert something or see how things looked a while back. I'm going back to the drawing board. And here's how you can do this. Whenever you have like a problem that you want to solve, or like in this case, a game that you want to implement in JavaScript, you're probably best going to start with a diagram, to sketch in pen and paper or in using an online drawing board about how do you think the program is going to work. So here's like an idea of how this designing process can happen. You start by thinking roughly the steps that make up, and then you start writing them down. So initially you start, your program will start by the first step, the first instruction, which is to just start the game. And then the next step would be to have the computer pick a random number. Okay, so the first step in my computer logic, in my computer program, would be to pick a random number. Then what is the next step that I'm thinking? Well, the user now has the chance to pick a number. So the user guesses a number, right? Now it's when the game starts becoming fun. And you can see this also looks like a step-by-step instruction. But once the user guesses a number, this is where the program logic stops being like a sequential, step-by-step way of going. And we have a case where two things can happen. So at this point, the user has correctly guessed the number, right? So if the computer picked 5, and if the user picked 5, right, we have one thing that might happen. But what's probably most probable is that the user has picked a different number. So the user has incorrectly guessed the number. So as you can see here, we have like now to split our program's logic into two branches, two different like directions. We can no longer say, do this, then do that, then do that. We have now to use what in program it's called a conditional or a branching. So I will now create like two directions here. And if this is a yes, or if this is true, that the user has correctly guessed the number, we go here and we continue the program here. Otherwise, the user has incorrectly guessed the number. So if the answer to the question, has the user correctly guessed the number, is false, if the answer to that is false, we go here. So in here you can say, in programming, we have conditional statements, which are questions. So something like this. So at this point, we'll need in our program logic to ask this question. We have a number picked by the user, but let's check whether it's the correct number. And right now, our program splits into two directions. So this is the essence of programming. When you have like a condition and when you have to make a choice, you have to split your program, and now your program can take two different directions. Okay? So let's follow this path where the user has correctly guessed the number. So the program right now, as I mentioned, if the user has picked 5, then the answer to this question is true, yes, and the program follows this direction. So we start thinking about what will happen in this route. Now, in this route, it's pretty simple. Then the next step would be to display you've won. Okay. And the program ends. So that's kind of like one route. Or maybe if we want to make this more fun, at this point, instead of just stopping the game or stopping the program, we might want to give the user the ability to restart the game, to go back to the start and play the game again. So either your program ends here or you play again, which means that at this point, we will have to find a way to redirect the program back here. So we'll have to find a way to say to JavaScript, to instruct JavaScript to go back to the initial instruction. This is also another powerful programming concept. You can just rerun some code again and again. So we have this route, and we also have the other route. In this case, we have the user incorrectly guessed the number. So let's say they picked, I don't know, 3. Or they picked, 7. Okay, all the numbers apart from 5. Now, how does this continue? Now, according to the game logic and the game rules, whenever the user has incorrectly guessed the number, we could do, well, a lot of things. We could say you've lost, right? And we can end the game and then play again. So that would be like one rule. But that's a little bit harsh to the player. Like just having one guess to guess a number from 1 to 100, it's impossible, and it's not fun. So instead of just throwing this simple logic, we're going to think about something that's a little bit more fun. Like as the game goes, you have like once again 2 options or 2 choices. Or let's say it diverges into 2 branches. So the picked or the guessed number is less than the random or the number the computer has picked. So if you have like 3, right? Or of course you have a number that's greater than the random number. In this case, something like 7 or 6 or anything above 5, right? So you have another branching, as you can see in our programs, which means we can also implement a conditional statement. We can use an if-else statement and ask the question here, is the guess, let's say, less than the random number? So we ask a question at this point in order to branch out and have the program kind of like, diverse and go through different directions. We have to ask a question, and based on the answer, which is always yes or no, or true or false, that's kind of like the yes or no for computers, we go to either one of these directions. So if the guess is less than the random, so if the question to this answer is true, we go to the left. Otherwise, if the answer is no, it means we are the number is greater. And how do we know that? Because if we went down this route, right, we know that the number is certainly not the correct number. Otherwise, we would have gone through this branch after this check, after this test. Okay, so we know that 5 is not in here, and the only cases we have is it's either less than or greater than the picked number. And we can continue our logic. So the guessed number is less than random. So what does this game do? Well, in this case, it displays your number is less than the picked one. Just lets the user know that they picked a number that is less than the picked random number, so they can make a better guess. Okay, we show something like this to the user, and then what happens? Display your number is less than the picked one. So we can either end the game, the user will not have much fun, or we can let the user continue by rerunning some portion of this program. So in this case, instead of ending the game, we would let the user guess another number. So guess another number, which means that in this case, we can go back here, right? This is where the guessing thing happens. We can let the user or the program continue, go back and continue from this. So we give the ability, the program gives the ability to the user to guess a number. We check if it's correct, they won. If it's not, we go back through this route. So at this point, it makes sense to go back to this point. And if I continue from this one, so if the number is larger, I display a message that says your number is greater than the picked one, so they can make a better guess, and then they can. And now we see that after these two paths, both of them go to the same like part, right? So they diverge right here. So after we have taken this path, either this one or this one, the greater or the less, our program continues like as like a linear, in a linear fashion. So we diverge to a single point, and then we have the same target. So that's how you can start by creating a graph, a diagram, or thinking about the game logic, the programming logic. It's always a good thing to sketch out what you think a solution to the problem might look like in a high-level overview. No code here, no programming language. And the idea is that if your logic is correct, you can check it. Anyone can check it, even if they're not a programmer. So you can verify it, you can have another opinion, and then you can pick any programming language you want. So the first step always to solving like a software problem or implementing something is by thinking, designing and sketching things out. Now, probably there are other things that I can add or improve here. For example, something that we can implement. I will not do this. Probably will not have enough time to do this today, so I will leave it up to you. Maybe right here on the step play again, we can think of another case would be, let's say, keep score. So as the user plays the games, we can keep a score. So first game won, second game lost, second game won, or maybe keep a track of how many tries, how many guesses, to see whether the player gets better. So we can improve the logic by adding some extra things. Now I won't sketch out what the logic would look like for keeping a score. I will leave this up to you, but we can improve the game logic by introducing some nice game features. And also in here, for example, I could say give a limited amount of tries. So instead of just giving the user unlimited guesses, just like I think in this game there is a limit, you can probably implement some logic that says how many times has the user guessed so far. 5 times, it's okay. Give them another guess. 8, 7, whatever guess. And if they go up to a limit, let's say 10 guesses, then you can stop the game. And this is where the user wins or loses. Because if you give them unlimited guesses, they will always win, right? After some point, they will always get bored or either find the random number. So there's some extra logic that you can implement to make it more like a proper game where there's a win or lose situation. But I will leave this logic at this point. Now, today, the content on WDX is about functions. So functions is a way to take a code, some piece of code, and make it reusable. So be able to say, okay, I want command A, B, and C to run again and again and again whenever I tell my program to do so. Okay, so function is, in simple terms, some reusable code that you can instruct the program or the programming language to run whenever you use the function name. So you have let's say, instruction A and instruction B and instruction C. So that's kind of like a simple program. Let's say it will run instruction A, B, and C. But if you want to run instruction A, B, and C when, let's say, the user clicks a button, not just when the program starts, but when they click a button. Or if you want to run the code, so if, let's say, user clicks button, then run this code. Or you want to run the code many times, right? Again and again, run instructions A to C again and again and again. Maybe these instructions download some of the latest news. So you want the user to be able to click a button and see whether there's some news, some new news, let's say, or some new, I don't know, latest changes. So if you want to reuse a part of the code, you use functions. So a function is just an enclosure where you put some instructions inside a structure. You give it a name. Let's name this play game. So you create a function. You define a function. You define that. You pick a name. You enclose the code that will be executed. And then when you want to execute these instructions, you just use the function name with a set of parentheses. So now every time in your code that you run this command, play game parentheses, we say that you're calling a function. So the computer will always will go here, find the function name, find the code, and execute it. Okay? So it doesn't copy this instruction. It says, okay, you say play game, which means I will go here and then run these instructions from top to bottom. In here, I will go again, run once again the instructions from top to bottom. So this is how functions work. They're just a way to put some code inside the bucket, give it a name, and then reuse it again and again, which is probably the most powerful and the most useful feature in programming languages. Otherwise, you have to repeat yourself again and again, right? All these instructions, repeat all these instructions all over the place, like here, copy them here, copy them here, copy them here, and so forth. And you don't have the control of running the code only when a special condition is met. So if I want to run, if I put my code outside of a function, it will always run when I run the program. But if I want these instructions to be executed only when the user clicks a button, I will have to use a function and then have the function get executed only when this event or this interaction happens. So they are really, really useful in our programs. So this is kind of like roughly how we can think of functions as reusable code that can be executed by calling, as we say, writing the function name with a parenthesis. And this is going to be very helpful to us in this case, because right through this diagram, we can find the reusable parts of the code. We have already pinpointed two cases where we want to reuse the code. One is the play again, right? So we want to reuse this code. And one is this part. So we have two places in our programming logic that we want to reuse that some code. So it makes sense in these cases to create a function. So I will start with a play again. So the play again means that the code to be reused, the code that we want to put in a function and run it again and again, is the game, the whole game. Start the program, we run this code, and when we reach this point when they are won and we want to start the game, we basically want them like to rerun the whole program, the whole game logic again. So it makes sense to create a function and put all the game logic in a function so that we can say function play game, right? So we enclose all this code inside the function. And then when we want to start the game, we say play game. You don't have to use the function. So this will run this code and it will initialize the application. And then also when we reach this point, when the user has won, let's move this here, we can run the function again. So you can see a function can also call itself, can also trigger the rerunning of itself. So at this point, when the logic goes from here to here, we once again call the function and we instruct JavaScript to just run this code from the beginning. So this is really, really handy when we have this kind of like reusable parts of our code. The second part that also can and has to be reusable is the guessing part, right? So when we reach, when we start here, we run, the code starts from here and it can go here, or it can go, all the way here, or all the way here. And when we reach this point, what we do is we want to run all this code starting from here again and again until, let's say, we have a limited amount of tries when we, let's say, stop the game. But for now, we just give the user unlimited guesses. So it also makes sense to put this part into a function because this part is also reusable, right? We call it once here. So let's name this function, I don't know, guess number. So we define the part of the code that should be reusable. We call it, first of all, we call it when the user ready to pick a number. So we should call this so that this code gets executed after the computer has picked a random number. And we also want to call this code again, right here. Because when the code reaches this point, we want to come back to the start and give the user the ability to guess a number, check, and so forth. So that can be abstracted away from this diagram. So what we do is we can move this thing. Let's say I can move this and clean this up. So we have this function. So now I have this function. I have this function here. I will just make it a little bit smaller. Now my game logic looks like this. First, there's a function, play game, that we start executing by calling the function name. At some point, this goes to this point and calls this function. So now this will call this function. And then this will also, remember, will call the playing game. It can also go back here and say, hey, run this code again. And the guess number can also call itself. So in this way, we kind of like found which parts of the code can be reused or have to be reusable. And when we go back to our code, we will have immediately two set of functions, like two functions that we can implement. And we will not start with a blank slate. We will have at least some indication on how to structure our code. We probably start by creating, two functions. And you can see that just right through this diagram, we were able to have a high-level overview of the logic, the structure, the flow of the game, and also how we can define several functions and make the code modular, as we say. So basically, all programs are made of a bunch of functions. Just like when you create something like a car, you just split it into different parts, and then you put them all together, and it acts as a car, right? You don't just start building a car. You say, okay, what parts do make the car? What parts do I need to create this machine? And then you start implementing part by part, and it's actually much easier than just thinking, okay, how do I build a car? That's why all programs should be, and all programming software problem solving should work this way. Break the problem into different smaller parts. Try to think of how to implement these smaller parts, these modules. Usually they are functions, and then you execute them and you run them and you reuse them. So this is what we're going to be implementing in our code. So now we're one step closer to our code. There are broadly two categories of functions: built-in functions, functions that are built into the language, into JavaScript, and they are quite a lot of them. So for example, if I want to fetch something from the internet, if I want to connect to a server and download some information, now in this case, I'm going to use a built-in function that a JavaScript has, which is called fetch. If I want to, let's say, set a timer like a clock, there's already a built-in function called set timeout. So we have these built-in functions that have already a name, and we have to learn them as we gradually learn JavaScript. And we have to make use of them whenever we want to do something. You don't have to build your own functions if you want to fetch something from the internet. You don't have to build your own function if you want to create like a timer. Whenever we don't have a built-in function for our game, for example, there's no built-in function in JavaScript for building or playing a number guessing game, right? So in that case, you have to define your own functions. You have to build your own functions. And the name that you pick should follow two rules at least. First is not to use the same name with a built-in function. So the play game should not be fetch, right? You shouldn't use a name from a built-in function. So that's a no-no. The other thing is that you should try to find a name that best describes what the function is actually doing. Start game, play game, init game, guess number, whatever. So the second rule is just try to see what is the name, and probably this will be a verb or a sentence that contains a verb that actually describes what this function is doing. You show that I picked play game for the overall program, which describes what I'm actually building a game. So I'm starting to the game. And then the guessing number is some code, some part of the program that gives the users the ability to guess a number and check their result. So the name was picked without, not just arbitrarily. It has to describe the actual logic of the function. So let's go into the code. Now, I'm going to need like two things. I'm going to make this very, very simple. I'm going to create a button that will start the game. Okay, I'm going to close this. This is going to be a very, very simplistic interface. Okay, we're just going to focus on the logic. Let me see if I can bring the number guessing in here. Let's see if this works. So I have my page here, which is automatically refreshed, reloaded after I make some changes here and I save. So live server will automatically detect the changes and the saves, and then will reload the page. Whenever you're building a JavaScript application or a website that contains JavaScript, is absolutely critical to open the console. So press F12 in your browser, go to the console, and this is where you're going to see everything that happens in JavaScript, whether it's an error, a warning, some log, some special message. So we never develop JavaScript applications in the browser without having the console somewhere on our screen. You can actually put it at the side, at the bottom. You can move it around. I like to have it at the bottom, but you pick what you want. But always have the console open, because if something wrong happens, you will not see an error if you have this closed. So we have this button that will start the game. And then in order now to write the program logic, I will have to create a script. Now it's programming language that I need. So I'm going now to switching from HTML to JavaScript. And this is what this script does. Now, what I need is to start a game. Let me have this diagram here and try to see whether I can. So I will start the game. Now I start not by writing code, by writing fake code, right? I describe in using the comments. So these are not JavaScript instructions. These are just comments for people and developers to see. They are not executed. They are just notes to ourselves. So I start laying out the code logic, the programming logic as steps and as comments. I don't start writing code, function, blah, blah, blah. So you first lay out your logic. So start the game, then pick a random number, then the user picks a number, and then check if the number is correct. Okay, so now this is the first branching. And now I will say, if it is correct, display win, and then restart the game. If it is not correct, trying to get as close as possible to my logic, to the thing that I have in my diagram and in my head right now. If it is not correct, check if the number is less than the picked one. So if it is less, display, less, let's say re-guess. And here, I will put an else here. So at this point, we check if the number is correct, and we're going to use this if-else statement. This first branching here is basically an if-else. This is the if, and this is the else, right? If something is true, go this way, other way, go the other way. So I'm going to say if else, and then in here, if it is less, do this and re-guess, else it is greater, display greater message, we will find this, and then re-guess. I kind of laid out the logic in as comments and as pseudocode, and now I can start taking a look, see whether my logic is correct, if I'm missing something, if I need to add something, and then you start implementing the code actually. So start by thinking, planning, designing, graphing, then move into the pseudocode area, sketch out inside your HTML or inside your JavaScript files the logic, and then we start implementing the code. So I can define here a function. Let's make it play game, because we not only start the game, but restart the game. So what we do is we use the function keyword. This is a special keyword, that's why you see it in orange here. And then we decide the name. So define a function using the function keyword, a name that can be anything you want. You put the set of parentheses here, which are for the being empty. You can put some parameters here. I will leave it as for other time. And then with these enclosing brackets, we're going to enclose the reusable code goes here. So in here, we're going to write the instructions that are going to be reused, are going to be executed every time we call the function. So this will be some code. Let me console log something. Okay, so this is going to be the function that is going to run just one instruction, which is going to log something to the console. That's another reason why we need the console. And this will show game started over here in the console. Now, nothing happens because once you define your function, the code doesn't run. You need to call the function. So first step is to define the function. And if you want to actually execute the code, you call the function. And you do that by using the name of the function. You don't have to use the function keyword now. That's only for the definition, for the creation of the function. Now you say play game and the two parentheses, and you end your sentence with this semicolon. And you can see right now, when I call the function, it finds the function and it runs the code. If I run this function again 4 times, the code will be reused 4 times. JavaScript went here and it ran this code 1, 2, 3, 4 times from the start. We have our game starter and we see that it works. For me, instead of just starting the game just like this, I'm going to comment this and I'm going to let the user start the game. I want the user to start the game when they click this button. So what I'm going to do right now is I'm going to go into the button and I'm going to use a special attribute which is called onClick. And this basically does what it says. It runs some code, specifically some function, when the user clicks on this button. In here, I will say when the user clicks, run this instruction. So right now, if everything is correct, if I click this button, the instruction here to the browser is when the user clicks, run this code. So run this function, which is going to log game started. So let's see. So you can see I clicked and now the game started. Now I no longer start the game just by initially calling the function. I let the user start the game by interacting with the button. So I can click again, and this shows me how many times I run this function, and every time I click, the code is run, this game started and is logged. So that's a good start. Now, here is a great lesson when you combine HTML with JavaScript. You write some JavaScript code, in this case a function, and then you can go into your HTML and you can say, when I click on something, run this code. Let me write another like silly example. Another function definition, right? And then console log, another function. I can call it and see the result in my console, or I can go here and I can say on click, header click. So when the user clicks on the start game, we will call this function. But when I click on the header, we call this function. So as you can see here, click, 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 and I get to run some code. So this is pretty powerful because your static content, your web pages now become alive. They can run code and they can interact with the user, which is really, really powerful. Okay, now the play game has all this logic inside it. So I will move all this pseudo code inside the play game function so that it's part of this main, let's say, game function. And I will have to start implementing all the logic in here. So pick a random number. How do we pick a random number? So first of all, we have to use const random number. We have to define a variable that can be like a constant with const. And at this point, I'm going to skip for now the algorithm that can truly pick a random number, let's say between 0 and 10. We'll talk about this later. In order for us to start and implement the rest of the logic, I skip temporarily the random number algorithm, which is just a fancy way of saying what commands do I need to run to get a random number between 0 and 10. I will implement the rest of the logic. And when I'm done with that and I have tested my logic, I will go back and implement the random number algorithm here. Let's go to the user picking a number. Remember the diagram. We are now going here. I'm not going to implement the function guess number at this point. I'm going to write the code and then I'm going to put it in a function box. So the user guesses a number. In this case, I will have like plenty of options on how I can let the user pick a number. You can see in this game, we have an input box and a guess button. We can even let the user speak the number. JavaScript in the browser allows us to speak to the microphone and say 5, 6, 67, which is amazing. The simplest one is, of course, to open a box, a pop-up box, let the user type a number, and then click, a button. The thing that we can do is we can use a command, a built-in function called prompt. So this prompt works like this: pick a number between 0 and 10. We'll start with a simple example. So this will show a message to the user, a pop-up. The message will be pick a number between 0 and 10, and the user will be able to add a value and store it. So if I run the game now, this is the message, as you can see here, and this is where I can write something, whatever I want. In my case, I will be careful and I will pick a number between 0 and 10. Let me pick 4, and you click OK. Now this function picks up this value that the user entered, and if I write nothing more than the prompt here, it gets lost. JavaScript picks up the number and then forgets it, let's say. But what I can do is I can store this in a variable by defining a constant variable called useNumber using the assignment operator, and this will pick up the number from this prompt pop-up and it will store it back into the user number. So basically this looks like this. The prompt function will pick up a number and it will store it to the left side. So the syntax is a little bit awkward because this function will be executed, it will pick up a number, and then it will assign this. This is the assignment operator, not the equality operator. This is going to assign the value from the prompt pop-up to the left side, which is the variable. So if I console log the user number, I will be able to reuse this variable and show the picked number to the console. So let's start this, start the game. I will pick once again 4, write 4, click OK, and now the number is stored in this variable, and it is shown in the console right here. And I can show it 3 times. Okay, I can reuse the variable's value. So right now, once again 4, and as you can see, the function, as we say, is a reusable code. So this is a function that accepts an argument. This is not a simple function with a parenthesis. You can also pass a value. So this console log will display something to the console. This is probably the most helpful command that we use to debug and try out things in JavaScript. So we have the user picks a number, and I'm moving on. And as you can see, my pseudocode now helps me create or develop the next parts. I don't have to scratch my head or think about it. I have the thing that I need to do right now, right here. So now I have to check whether the number is correct. And I will do this with an if statement. So if user number, and now the equality operator, when we want to check whether 2 things are the same, there are 2 things, there are 2 operators, this one and this one. Both are checking whether 2 values are the same. In here, I can say 3, 3, This is true, but this is false. Okay, and both of these work. Now, you might be wondering at this point what's the difference between the two. I'm not going to into the difference right now, but there is. Okay, they're not doing exactly the same thing. In our case, we're just going to use the double equality operator for the game, and we're going to see whether we are correct. So if the user picked number is the same as 5 as the random number, we will say console log to 1. Else, we're going to say console log. Let's say we've lost for now. So right now we go into the first branching. This part is where our program splits into two, diverges into two different routes. This if route happens only when this is true, when the user number is the same as the number, and this happens or gets executed only if the numbers are different. This is this part here. This is how we add this in code. Let's check now the game. So remember, the random number is not exactly random, it's 5. So if I pick 4, I lost. If I pick 2, I lost. If I pick 5, I won. So now we have our first branch. And if it is correct, we say display win and restart the game. So I will move this here. So this is the logic that belongs into this branch. So this pseudocode reflects this part, right? We've gone towards the route that has the user has picked the correct number, and we can also, now implement the else part. So here is the thing. Now restart the game. At this point, I could run play game again and rerun the game. So let's check if I do this. So I click 5, which should be correct, and I should see. And now the game starts again. It's really fast. It's, as you can see here in the console, it says you've won, and it starts the game again, which is not extremely helpful. It's annoying. I didn't actually see the you've won message. So I'm not going to I'm going to restart the game manually. I'm going to just let the user click the button. They will start the game, they will win. And then if they want to play the game again, they will just have to click the button again. Okay. So the restart game right now will be a manual process. But I need the function. I put all this code, all this play game in a function, because otherwise I couldn't reuse it like this whenever the user clicked. The only way to run some code again and again is to put it in a function, so that it's a reusable kind of like piece of machinery. So this branch we're done with this. And I can also, instead of console log, I can also alert, which is probably what we need to display to the user, because the user will not have their console open. They want to see something on their screen, right? You won. Otherwise, the console is something that no normal user opens. And sometimes we also normally we display things right here. But for now, we'll keep this to a simple alert. So console logs are for the developers. Alerts or other things that we display in the page are for the users. So keep console logs to yourself, let's say. Okay, the first branch is easy. You've won. And then I can move all this code, this pseudocode here. So now we're in the else statement, which means that the number is incorrect. And we need to do another check here to check whether if the number is less than the picked one. So that's another branching inside the branch. So you can see here we have two branches. One goes to the left, the other goes to the right, right? We have this branching. And now once we are inside the else branch, once we are here, we have another branching. So while we are inside the else, we have another if else. And you can put as many if else as you can. Now, inside this second right branch, I will say if user number is less than random number, we do something. So if it is less, we do something else. Else, if it is greater, we do something else. And as you can see, I move my pseudo code around, so it will help me kind of like focus on a particular code block, okay? Because the if it is less logic goes here, and if it is greater, logic goes here. And what does my pseudo code help me do? This is really helpful because if I close my computer today and I open it up 3 days from now, the pseudo code will help me quickly see where I left off and what I have to do. I see now that I have to display a less message and reguess. So I will say alert, my number is, oh, sorry, let's say your number is less than my number. And in the other case, so if it's greater, your number is greater than my number. So we can help the user pick either a less or greater number and go further. So we have once again a branching. If else, this is now this guy here. Our logic, as you can see, is implemented as pseudocode, and now it is further implemented as code. We are here, the display is an alert, and let's see whether that works. So I will start the game. I will pick 3. Remember that the random number is 5. So your number is less than my number, and it ends there. And let me pick 6. So 6 is greater than 5. Your number is greater than my number. So now I can just lower my number. So instead of picking 7 or 8 as the next number, I will have to pick a number that's less than 6, right? So that's kind of like how the hint helps me go to a different. But the problem at this point is that the game stops here, right? The idea is to give the user a few guesses. So not just lose with the first guess. So now I have to create another function that will become a reusable code that will give the user the ability to guess and guess and guess again. Now, in order to do that, I will have to find the code that I have designated in my diagram, like where is this guessing part of my code starting. In my diagram, this this red block was put in the description here, which says the user guesses a number. So right when we give the user the ability to pick a number, this is where this function guess number starts. So I'm going to use that and try to find that point in my code. You can see here the pseudocode once again helps me pinpoint that point. Maybe it's a little bit harder just by looking at the code, but the description here looks exactly like my diagram. So pseudocode 1 again. So here's where the guessing number part starts, and I'm going to fold some sections and see here where it ends. So this whole thing is the part that needs to be placed in a function so that I can reuse it again and again. So instead of having this like this, I'm going to define a function called guess number. I can define, as you can see, a function inside another function. That's totally normal in JavaScript. And I will move my code in here. Okay, let's unfold it. So now all the code is now in a box. This is the container. So this now code is inside this box. And I can fold it, and I can also hide some of this complexity. And I can reuse this code just by calling the name. Just by saying guess number parentheses, I can call this code again and again. So when I play the game, I need, after the pick random number point, I need to start the guess number process, right? Otherwise, if I start the game now, the only thing that happens is the program starts. The random number, let me console log it. It will be console logged, and that's it. But the game will stop there. The function definition doesn't act on itself. It's just a definition, just a setup. It doesn't call any code, it doesn't execute any code. In order to call this function's code, all the things that inside here, I have to call the function here. So I define the function and then call the function to execute. Otherwise, the code will never execute. So now I start the game and the code executes. So the whole code here starts working. Let me put 3. Your number is less than my number. Okay, everything seems to be working fine. And then it stops. And it stops because this code, when it reaches this part, or when it reaches the greater than, so if I put 8 or 555, it says your number is greater than any number, right? So we are here, and then it stops. That's it, end of the game, end of the code. But if I want to go back, continue this code, to reuse this code, to rerun the guessing, I will have to, at this point, call the guess number so that when my branch finds itself here, I rerun the guessing number again. Or if my branching goes in here, we call this function again. And we can call function even within the body of the function. So we can call this function while we're inside the function. This is really, really powerful. So at this point, I can say if if the number is less, then give the user another the ability to guess a number again. And else, if the number is greater, also call the code again. So at this point, both at the end of these two branches, in both here at this point and both at this point, we are calling guess number. So both of these endings will reach out to the function and call it again. So there's a feedback loop. So it will run, it will go again, blah, 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 and you will see there's an ongoing cycle. And this will run forever until we win, right? So let me run this again. So I will put 3. Your number is less than my number. Okay, pick a number. Let me put 4. Your number is less than my number. Okay, 5. You won. Edit any tens. And then, of course, let me test again. I will start with 3. 3 is less than my number. Okay, let me put 8. Greater than my number. Rerun guess number right here. 7, still greater. 6, still greater. I'm subtracting. 5, you won. And so the whole loop works like this. And the last thing I can do here, this works, is fine, okay. But right now I did this thing. As I was here, I ran the code, the guess number again. As I am here, I run the code again. So guess the number, called here, guess the number, called here. But you remember that after both of these branches complete their their logic, they diverge both at the single point. So after this branching, after this if else, right, we end up, our program can continue through a single flow. There's no more branching in here. So they both diverge in the same point, and they both can continue. So instead of having the guess number here and here twice, I can put it in here because both roads will end up at the same point, right? So think of this as 2 roads. They diverge, they go around the block, but they find themselves on the same road again. So if I put the guess number instead of here, right after this branching, the code will run and the user will be able to guess the number again, no matter whether it was greater than or less than, right? At this point, we don't care whether the number was less than or greater than. We want to give the user another chance of rerunning the logic. But even if I were to put this guess number here and here, it would still function in the same way. This is kind of like an optimization and simplifying the logic a bit. We need to do some thorough testing, okay? Don't just test your program once or twice and say it's okay. You have to thoroughly test it and try every single thing that you can think of, like adding really, really large numbers, or just keep testing, keep trying numbers. Will it break at some point? Is it going to be working? So we have to be very, very thorough and strict with our tests. You have to think your software as testing a car. Whenever a company, an industry tries or prepares a car for the road, they don't just put it out on the road. They put it through crash tests. Like they crash it again and again until it becomes safe. It's safe and secure enough to put it out there in the road. This is what you have to keep in mind. I have to find a picture here. This is the most important part of our job. We have to keep crashing our software before releasing it out to the public. This is what we do all day long. We create cars. This is really important. We're not just creating simple games. Our software runs the world. Our software will affect other people's lives. So we have to crash it again and again into our labs, into our computers, before we push it out there and we have other people, simple, poor users, crashing or having problems with our software. So it's really important to test or crash test your program again and again until it becomes safe and secure and it behaves as it should. So that's kind of like the game. I will add the line that is going to give you a random number between 0 and 10, and we'll explain this next time. So this is going to be a long, I will explain it next time, what this does. We'll take it apart next time, just not to overload you today, but this is basically a line, which will make more sense next time, that gives us a random number between 0 and 10. So let's test it. So we have 2, as you can see here. Let me just win. You won. Start the game and again. Now a random number, 8. We win. Start the game and again. It's 10. Again, 3, and so forth. So now we have a simple set of built-in commands are basically picking up a random number and doing some mathematical calculations to actually give us a number between 0 and 10. And now we have like a almost fully functioning number guessing game.